You're listening to Materials Business, the podcast where engineering, leadership, and innovation meet diversity and inclusion. Hosted by Monica Hernandez, engineer, entrepreneur, and industry advocate. When we embrace different perspectives, we create stronger industries, smarter solutions, and lasting impact. Now, let's dive in.
Good morning, good afternoon, or good evening, depending on when are you watching us. And thank you for being part of the material business community. My name is Monica Hernandez, and I am your host. And I have wonderful Alec with us once again. We are going to continue the series that we started some months ago about corrosion and AI and the integration. There was really good feedback from you, the audience. Really good feedback personally to me, to Alex. So that is what we want to promote. We want to share knowledge and promote community. So here we are again. Thank you, Alex, for being with us once again.
Thank you. Thank you. Wonderful.
So I will not, maybe for some people that don't know who you are, do you mind introduce yourself quickly?
Yes, only 2 words maybe. Yes. I have experience in all fields of corrosion, nearly 50 years. And I worked, about 16 years before 1990 in the Soviet Union, former Soviet Union. And now I work 36 years in Israel. And I have several legs. Yes, the first, this is experience in industry, R&D, yes, in oil refining and petrochemical and chemical industry. I was a head of corrosion materials laboratory in oil refining company in Israel. Then I have experience in academia because I also have teaching, teaching and education. Yes. And the third, this is dissemination knowledge about corrosion because I am a member of our Israeli forum, which was organized by new repatriants in 1992. And every 2 years, we organize our annual corrosion big conferences. And during the year, we organize seminars, meetings, excursions in all our corrosion laboratories, in both in industry and academia. And I also, as a member of international organizations, AMPP, former NACE, and EFC, European Federation Corrosion. And now I wrote 4 books, 4 books in corrosion. The first was a wonderful book for everybody, and this means for you and for all our attendees and listeners. And I think that this book was recommended in about 13 years ago, by American readers, well, all readers of NACE, now MPP. Yes. And now I wrote a big book, about 750 pages in Hebrew, the first book in Hebrew as our Bible. Yes, maybe anybody wants to translate. This is modern book that encompasses different achievements in corrosion and corrosion protection, corrosion monitoring, corrosion management, and so on. And now I am an author of many chapters in corrosion. And the last chapter in Encyclopedia of Aviation Fuels, yes, and now in December next month, will be published by Springer. In my chapter must be 13 about corrosion in aviation fuel systems. Now we're also with my colleagues from EFC, European Federation of Corrosion, from Working Party 15, corrosion in refining and chemical industry. We prepare a new book about biofuels and corrosion by biofuels. I think it's enough. Yes. Let us continue our meeting.
Let us start. That was a wonderful introduction. So thank you for your time, everyone that is listening. We're going to have a really good and animated presentation. Alec always prepares the slides, and that helps a lot the audience connecting the concepts. So I'll let you start sharing and start the conversation.
Just a moment. Oh,
wonderful. We can see it. Perfect.
Okay. Thank you, Monica. I live in a small village in the Lower Galilee in Israel, 40 kilometers north from to Haifa and 30 kilometers from Acre and Nazareth, at the distance about 10,000 kilometers, above 10,000 kilometers from Vancouver, Canada, the place of Monica living. However, we feel that there are no distance and borders for us scientists and engineers. This is my working place in the garden with beautiful flowers. My wife and friend Olga grow these flowers, trees, bushes, and shrubs around. This is my email and website where you can read a lot about me, my works, and my activities. Our generation is visual one. Therefore, I prepared this podcast, the second podcast, with pictures and photos for better perception and understanding of discussed material. Look around. There is no place in life today without artificial intelligence, AI. Each person who deals with metals feels how many problems and mysteries exist around corrosion subjects. Thus, several months ago, we with Monica decided to begin a series of conversations about application of AI in solving corrosion problems. I like to begin with the epigraph. Today, the epigraph of Mota is there is no shame in lack of knowledge, but in the unwillingness to learn, by the ancient Chinese proverb. I would like to outline our topics in today's journey into the world of corrosion and materials and the application of AI in solving corrosion problems. Usually I begin my lectures for students with a question. Do you know why among Nobel laureates so many Jewish? Because Jewish children ask many questions. We also begin our discussion with the questions. Corrosion kinetics. Where are we? How correctly to determine the corrosion rates of metals? Can the data from reference books and encyclopedias about corrosion rates of metals and alloys in various media be used? How can we choose the optimal concentration of inhibitors correctly? It is important because most of my young colleagues, practical engineers, and scientists requested to highlight these issues for their job. Defining a problem is a halfway to solving it. Do you like jokes? Here is one of them. A Jew came to the rabbi and told him, I have so many problems. The rabbi answered him, listen me, God gave everyone problems according to their abilities. If you can't solve a problem, then it's not your problem. And we corrosion professionals can solve these problems, but not alone, or otherwise we continue living with these problems.
Mhm.
Now, thus to solve corrosion problems using AI, the following conditions are necessary. A wide range of data, big data, data science, data mining for each problem, accessibility of all data available in the industry and academia. And unfortunately, most companies store these data without sharing them. Participation of computer scientists, mathematicians, and physicists in solving corrosion problems. Today, let me remind you that today before the podcast, I asked many of my young colleagues, scientists, and engineers which topics they would like to listen. I do according to their wishes. Today, we will answer two questions. How to determine correctly corrosion rates of metals and how to choose the optimal concentration of corrosion inhibitors for the minimum needed efficacy. In spite of these simple or easy questions, there the problems maybe, and most young engineers who deal with corrosion anxieties, is requested to explain this. And let me remind you the definition of corrosion of artificial intelligence, AI. AI is a multidisciplinary branch of computer science that aims to create machines and systems capable of performing tasks that require human intelligence. Shortly, this is an animation of human thinking. AI is based on the following fields of methods: probability theory and math statistics, rules for differentiating complex functions and matrices, and linear algebra. You see, we need mathematician. This is a general scheme of application of artificial intelligence in corrosion science and engineering. When we are talking about AI, this is a big field like chemistry, biology, physics, medicine. Nowadays, AI is an engineering discipline. AI includes ML, machine learning, a type of AI dealing with the development of algorithms and models allowing computers to learn from data examples and make predictions. It was intensively developed in the first 21st century. Machine learning is used in a variety of industries that require future prediction. Neural networks began intensively using in this period. The idea was that neural networks should learn like children. Deep learning based on neural networks was developing during the second decade of the 21st century. Now, we are witnesses of the developing generative AI in the third decade of the 21st century. The main our goals to receive from data obtain knowledge. Here is the scheme how from data we can obtain corrosion knowledge. Neural networks are a type of machine learning. Neural networks represent developing and training models that imitate the functioning of the human brain. We are introducing input data, for instance, pH, temperature, velocity of media. This is input layer. These data are being processed in the hidden layer representing the machine brain. We obtain results in the output layer. Corrosion rate or pitting tendency, their output data. This is a general scheme for any neural networks. Corrosion kinetics is the study of the rate and mechanism of corrosion reactions. While thermodynamics tells us whether a corrosion reaction is possible, kinetics explain how fast or slowly it will happen. Why it matters. Understanding corrosion kinetics helps us in predicting material lifespan. This relates to our first podcast meeting where we talked about prediction models in June, several months ago. In thermodynamics, we can use in thermodynamics, we can use only calculations, namely a paper and a pen. Here I would like to emphasize the greatness of thermodynamics. I took part in the Eurocore 2025 in September this year in Stavanger, Norway. By chance, I listened to the lecture about inside corrosion of galvanized firefighting pipes. A presenter said that iron does not corrode in the absence of dissolved oxygen in water, according to the diagram of Courbet. Why? If this fails or not? If it fails or not? This follows from the electrochemical theory of corrosion. Anodic dissolution of iron and cathodic reduction of oxygen occur in neutral and alkaline aqueous solutions. This means that if no dissolved oxygen, no corrosion of iron in water. Are you sure? Let us continue analyzing how the cathodic reactions can take place: hydronium reduction of ferric ions, cations, Fe3+, and reduction of magnetite, Fe3O4. These components are present in very low concentrations in neutral water. Therefore, these cathodic reactions are negligible. However, they can occur. What does thermodynamics tell us? Let us calculate changes of Gibbs energy, delta G, for two corrosion reactions of iron in water with the formation of iron oxide, hematite, FeO, and hydrogen gas, and ferrous hydroxide and hydrogen gas. As you see, delta G is negative in standard conditions. This means that these two corrosion reactions are spontaneous. You can find these calculations in my first book, Corrosion for Everybody. Spontaneous does not mean fast. Thus, thermodynamics says, yes, for corrosion of iron in water that does not contain diesel oxygen. However, we should take into consideration kinetics. Kinetics said that the rate of these corrosion reactions is very low. For some metals, for instance, aluminum, titanium, stainless steel, because of formation of passive oxide layers, corrosion processes are stopped. Kinetics and thermodynamics. Thus, in all corrosion processes, we should consider both thermodynamics and kinetics. What is more important, in my opinion, kinetics. Why? Because thermodynamics says yes for many corrosion reactions, but kinetics says no, even for iron. Because of formation of iron oxides and hydroxides, the rate of corrosion reaction of iron in neutral media is low. In kinetics, there is no reasonable theory to calculate corrosion rates. However, different laws can be used for high temperature oxidation of metals and alloys: linear, parabolic, cubic, logarithmic. In most cases, there is no kinetic theory of corrosion, and we should carry out an experiment. Similar situation occurs in chemical kinetics for reactions between two phases: solid metal liquid or solid metal gas. In any project, we want to know how long this construction will serve without failure. This means we should know corrosion rate of construction. We should know corrosion rate of construction material in some medium, namely predict behavior of material in medium. Sometimes, rarely, we can find such data in books or encyclopedia. In corrosion rates, we determine experimentally during short period of several hours or days. This data can be questioned. Why? Because corrosion rate depends on period of immersion of sample in medium: 1 hour, 8 hours, 24 hours, 96 hours, 1 month, 1 year. I was asked many times, how long should we wait to determine corrosion rate of some metal in media? And this is a very important slide. How can we define corrosion rate correctly? This is typical for kinetic curves of ion corrosion in water, soil, and atmosphere. We take 10 or 20 metal coupons and metal samples and measure corrosion loss in time. Duration of the test depends on metal type and the environment. We build the curve corrosion loss against time test duration. This is a typical curve for kinetic curves of iron corrosion in water, soil, and atmosphere. Then we calculate corrosion rate as a differential slope gradient in each point of time. We reveal that for short period, you see, high corrosion rates are defined. After some duration period, stable state is reached. Only after this period, corrosion rate is constant. This value should be used for practical needs, because if we take This the first data of corrosion rates, the first short period. Yes, of course we will mistake. Now let us define the minimum efficacy for corrosion inhibitor in some media. How should be this value? 60, 70, 80, 90, 95, 99, or 100%? I came across data that some scientists and engineers said the more efficiency of corrosion inhibitor, the better. Even some scientists, for example, say that in the oil industry, the value of 95% efficiency is accepted. Why not 90 or 99? This is a wrong opinion. Why? Because for each industry, for each equipment, there is accepted, allowable, permitted corrosion rate, which depends on wall thickness and service life. As you see, when we know a real corrosion rate, we should measure, of course. We can measure this and we can calculate the accepted or allowable permitted corrosion rate. We can calculate the minimum efficiency for optimal concentrations of inhibitor. In this case, this is only example. For example, for oil refining industry, heat exchanges in the overhead of different distillation columns. Only inhibitors with above 83% must be choose. As you understand, as we don't need 90%, 95, 93, but less than 83%. It's wrong, of course. Now, it is the time to show how we can use AI in each of these research work. We create neural networks. We introduce input data, temperature, pH, chemical composition, velocity, all data you need and have. This is an input layer. These data are treated in the hidden layer. We obtain this is brain of our neural networks and hidden layer, and we obtain output data in the output layer or corrosion rate. Then we calculate acceptable, allowable corrosion rate. This value depends on the equipment type, wall thickness, service life, conditions. It may be 0.1, 0.2, 0.3 millimeters per year. It depends on the industry. It depends on conditions and, of course, of unit and concrete equipment. Therefore, you cannot take just like that any value as you want. As usually young engineers take 0.1, but this is wrong. As a result, we obtain allowable corrosion rate. At last, we calculate minimum efficacy E. That means a new neural networks. And we introduced a real corrosion rate and accepted allowable permitted corrosion rates. These values are treated in hidden layer our brain, and we obtain a minimum efficacy E. And of course, in all the examples, yes, I showed you, and these topics relate to corrosion education. We must give instruments to new educators and teachers how to teach, how to educate, how to give new junior methodology and attract young generations of students, engineers, and scientists to learn corrosion subjects. So, what can we say today in the conclusion? I carried out the searching of publications about AI in corrosion. AMPP, the Association of Materials Protection and Performance, COMANACE conferences for the last 33 years, 1992-2024. I found only 12 papers about artificial neural networks in predicting pipeline corrosion and emerging AI technologies for corrosion monitoring in oil and gas industry were published by non-corrosion journals. To sum up, the first, AI has become an engineering discipline dedicated to solving practical problems, and all our problems, corrosion problems, may be solved by means of AI. The goal of corrosion specialists is similar to that of meteorologists. Meteorologists that predict behavior of weather. We forecast the behavior of metallic equipment and construction. And the third, we need to attract mathematicians, physicists, and computer science to our field. I remember then after meteorologists, yes, they attracted mathematicians, physicists, and computer science. They begin to predict uh, better the behavior of weather. No, and the last that I'd like in this meeting podcast to say, what about our podcast in the future? Maybe myths about stainless steel, or does stainless steel rust? This topic maybe the next podcast 3 if I interested you. Thank you.
Thank you, Alec.
Yeah.
Fantastic presentation as always. And like Alex said, majority of this series came up with the the feedback that we got from you guys, the listeners, the audience. We are still seeing your screen, Alec.
My screen?
Yeah.
Okay.
So what
Full?
we are trying, you're still sharing your screen, right?
Yeah, it's okay. Is it okay? No.
Sure.
Sorry.
Maybe you can stop sharing and then
To stop or no?
to stop. Yeah.
Okay, just a moment. I will stop. Stop. Okay. Yes.
There you go. Perfect. Thank you.
Yeah.
So I was telling to the audience that this series came up from the feedback that we got from you. Some time ago, we sent a short question, like a survey, but it was like 1 or 2 questions. And we just wanted to know which topics do you wanted to see. So today's material was prepared by Alec based on that feedback. So now the proposed for the next one is stainless steels. I love the idea. So you, the audience, have the opportunity to participate. If you see that there is something different, reach out and we'll consider it. But that's the idea, that we come in here, we learn a little bit about what we are seeing. Alec is very active. He's brought material from the latest conference that he attended some months ago. So you guys are getting really the best news and the best material from here. I really agree with the fact that, and you said it in a really good way, when we are predicting corrosion, a lot of the times we see companies that use like a blanket statement, or let's just use, in this side of Canada, we use 5 MPY, or like whatever, 1 MPY, or meals per year. And they will just go like, okay, carbon steel, just use 5 MPY. And that is completely what we are here to say. We need to really think about what values are we using, because that will determine your lifespan, and that will determine how much are you going to need repairs, or where or when are you going to need them. So, and the last thing that I want to tackle down is, and I wrote it here, is collaboration. And we speak about collaboration in this podcast all the time. We need to have people in the room that are able to give us the tools and the knowledge and the skills that we don't have. And together we make a biggest and better solution than working on our little silo. So big things that you shared. Thank you, Alec.
Thank you.
One last message to the audience. What do you want to tell them?
Oh, yes. You know, that to audience, yes, I was saying that we live now in the world that changes very quickly. Yes, very quickly. But our subject of corrosion, unfortunately, does not change. Is not changed. Is not changed, and other topics are yes, all other parts of our world. Why? Because once again, we should introduce now the methodology of AI, artificial intelligence, in corrosion science and corrosion technology, more and more. But without computer scientists, without mathematicians and physicists, without their attraction, we will not be able to succeed in this. And to attract young generation, it is very interesting that in EFC, European Federation of Corrosion, several years ago was organized, I think, young section for students of PhD, postgraduate, and young engineers and young scientists. And after this, for example, after this attending of the last conference in September in Stavanger in Norway, there are many, I think several hundreds young students, PhD and postgraduates. And they wrote me after our meetings, we'd like there is mentor-mentee programs. They wrote me to be a mentor. Yes, and it doesn't matter which university, because in universities, all the professors, yes, I know, I work with them. They're my friends. They have great experience in science. But unfortunately, these professors do not have experience in industry. Therefore, we should attract more and more engineers from industry, as you, as many others. They can only help because they have tacit knowledge. What is tacit knowledge? That is in their heads. Yes, therefore now we should take this knowledge for young generation. Therefore, mentees, I have now several students as mentee, and as a mentor on different corrosion problems, because for me, there are no problems water CO2 corrosion or corrosion and subcritical CO2 and any other problems. Yes, we have this to solve, but once again, to concentrate, of course, with the attraction of mathematicians, computer scientists, physicists, yes, to include in our investigations new methodology of AI.
Perfect.
Yes.
Perfect. Wonderful. Thank you, Alec. Thank you to our audience. Keep on here. Congratulations to everyone that has an opportunity to talk to you, because that is going to be huge for them.
Okay.
Thank you for being here. Thank you to the audience. And then keep on being tuned. And if you find that this will help someone, just share it to them.
Oh, just a moment. Yes, I'd like to remind because I have now also in contact with some new students. Yes, postgraduate, I think, students from Stockholm. Yes, they connect music with chemistry. And this is one of my great topics, to connect corrosion science and engineering with humanitarian aspects of our life. Corrosion in materials with art, with music, with humor, with philosophy, because what is the main task of our life? Do you know what? I ask all my new students, why do you live? Why? Yes, what is your main task, aim? Yes, goal, to look for beauty. Therefore, to look for beauty, we go to museums, to cinema, to theater. Yes, this is beautiful picture. This is beautiful girl, the beautiful boy. This is beautiful mathematician equation. Therefore, beauty is in corrosion, science and engineering. When we connect, yes, we find this interaction with corrosion materials, with humanitarian aspects of our life. This is my note for today, our podcast meeting.
Thank you. Thank you, Alec. There you go. I think there is a lot of beauty in what you're saying. Is like if you find a way of looking at everything with those eyes, is like, oh wow, this is amazing, right? So yeah, definitely. Thank you so much for being here. Thank you to everyone that has tuned in, and then stay tuned because we'll continue the series with wonderful Alec, and then we'll have some other guests in our podcast. Thank you so much.
Okay, thank you for organization. Beautiful one.
Thanks for listening to the Materials Business Podcast. Feel free to visit infinitygrowth.ca to see show notes and explore other episodes. If there's someone you think should hear this episode, please share with them. Take care of yourself and have a great rest of your day.